on any sort of interesting things that we'd found, or just even to say like we're done with this host, we're done with this port, whatever. And then also we found in previous tests that we needed something that was kind of robust. If you're running a scan that's taking several days and for some reason it dies in the middle, often you kind of end up having to start from the beginning. Sometimes that's because things get randomized and you don't have a good way to know where you were. This is Nepenthes, maybe. Yep. And then, so we wanted to be able to basically just kill off everything and start it back up and not lose a whole lot of data. We know that we might lose the exact thing we're in the middle of, but we didn't want to lose everything. So, pick your starter here. A bunch of different options that we can start with. Some of them are considered okay for this sort of thing. Obviously, Nmap is kind of what you're expected to do in a lot of this situation. Nessus is also kind of useful for doing these scans. I'll talk more in detail about each of these. We tried to split things up with parallel, which is weird, but whatever. Mass scan is also an option for doing large scans. There are a few other options that also came up. So Nmap is the nobody ever got fired for buying IBM version of the port scanner. It works well. It does a few things that will kind of slow itself down. It was more or less written for slower network connections, more flaky network connections. And so, if you give it a large range of hosts and some of them aren't responding at all, it will keep slowing down because it thinks maybe it's just dropping packets. There are options that you can use to limit that, but we found that even, trying to sort of tightly constrain Nmap, it was more difficult than it should be. And we also found that even with decent sets of options, just running 2 copies of Nmap with different ranges gave more results and faster. So we wanted to be able to split that up as well and not just rely on it as the one tool that we were using. Nessus is nice, has lots of features, has lots of plugins. That's kind of, as far as I'm concerned, the main benefit of Nessus is that you don't have to write plugins for each of these things or tools or whatever. Tenable does a pretty good job of getting out updates to it when there's some new thing that you can check for remotely. There will be a plugin in Nessus in not all too long. However, we found that it was kind of slow for doing scans. It kind of fell prey to a lot of the things that Nmap had as issues, as well as some of the tuning that you would need to keep the normal Nessus scans that would actually test for vulnerabilities from being too disruptive, meant that the port scans ended up going more slowly. And we also found that for whatever reason, we could scan the same host a few times, no changes on the host, and get different ports that came back as open. Sometimes it would miss finding fairly obvious things that should have worked just fine. We had this problem with, I want to say Heartbleed, where sometimes it would detect it and sometimes it wouldn't, on a host that we knew was vulnerable. So we didn't necessarily want to depend on it a whole lot, but it's, obviously, if you're doing Netpens, you've probably either used it or at least heard of it. So again, talking about splitting up Nmap, we did consider using parallel and just split up Nmap into smaller runs. And we actually did this a few times. It did go faster, but it was not really what we wanted to do. Just kind of move on from there. Mass scan, at the time we were starting Unicorn scan was I guess, the more initial one there. Those sorts of tools that basically just sort of spray out a bunch of packets and wait for responses are very useful for scanning the entire internet, especially when they go randomly, but it is not particularly great for a lot of our clients. A lot of our clients, even if you're just doing 1 or 2 scans with Nmap, their network team will call us up and say, hey, our switches have too much utilization. Please stop. So we figured that trying to integrate something like mass scan might not work out too well for them. It also doesn't have as many of the features from Nmap that we'd want, but still could be useful to integrate into some sort of tool, just because it has the advantage that it's significantly faster. So it might get some of the easier to catch ports and get more data faster. And then it sort of became to the option of just make a new some new tool to manage scans, which seemed kind of absurd at the time, just because there was a lot of effort that had to go into it. But we decided to do it anyway. It was not all terrible. Named it Nepenthes. Nepenthes is a carnivorous plant. Got a picture of one there. And if you sort of squint at the name, it looks a little bit like Netpen test. So figured we'd go for it. There's sort of a simple architecture for Nepenthes. There's a sprout that just manages everything. It's built on Rails, uses a MySQL database, uses Redis. Sidekick manages jobs for it, which is similar to Rescue or Delayed Job if you've used either of those with Rails. Then there are tendrils that are basically do all of the work. So they'll do the port scan, they'll check host names, they'll do ping, they'll do SSL checks, anything else that we have as work to be done will be done by a tendril. And then they communicate with each other via Redis that's just sort of exported via an SSH tunnel. So the Sprout SSHs out to the tendril and tunnels back a Redis connection. So you can transfer data there, but there's no direct database connection from the tendrils. So that's kind of nice. The Sprout itself then basically stores all of the data, hosts a web UI that gives access to pretty much all of the data and lets you start different things if you want to start them. You can initiate scans from that web UI. That's a little bit limited so far. You can also initiate scans from the Rails console, which basically just gives you full Nmap options because that's what we're using to do actual port scans. You can write your own workers to do other things. And then it also, we say it supports multiple users, which is basically just the fact that it's a web interface and multiple people can use it at the same time. It doesn't track things separately, but the idea is that I can send a link to somebody and say, hey, look at this host, something doesn't seem right here, or we should investigate this further. And so that's something that we've done a fair amount in tests. Then the tendrils themselves are workers. We just put them on relatively inexpensive virtual machine hosts from various providers. Don't necessarily want to endorse one over the other, but a lot of providers are okay with you scanning from them as long as you're scanning people who've said it's okay. And all of our clients obviously say it's fine for us to scan, so that's not an issue for us. But if you're going to be doing scanning, check with your provider first. Nothing ever hits disk on the tendrils, so if you have sensitive data that you're concerned about, at best, anybody who takes over a VM provider that you're using will get what you're scanning and the immediate scan results that they'll see when they're looking at it. They won't have any of your notes. They won't have any of screenshots or whatever that you've taken that are no longer on there. And then this scales relatively well horizontally. So if you need more workers, you can add more workers. We've gone up to I believe 8 reasonably well-powered workers to scan a /8 on the internet, and that worked out pretty well. So, and the idea is, if one of these dies, nothing bad happens. Those jobs will basically just get requeued. You can completely kill them off, and everything should still work just fine, which is a benefit for us as well. We had a few other goals when we were writing it. We wanted to make it easy to extend because sometimes you're in the middle of a test and you say, well, I need the data in this way, or the client wants some other type of report that we hadn't had before. The idea was to keep it mostly idiomatic Rails. So if you're familiar with Rails, or realistically if you're familiar with Python or some other high-level language, you can pretty much jump in and make some changes if you need to. And we almost had an explicit goal of we weren't trying to make this a long-term deployment thing. So if you needed to just make quick patches to it to make some future work that you wanted to add, that's basically just fine. You're kind of expected that if you need to write code, it doesn't have to be the greatest as long as it works. But we also don't have any sort of differences to say well, a month ago this port wasn't open and now it is. That's a feature that might be nice to add, but we don't have it yet. So I'll do a bit of a demo here. Oh, actually what I want to do. Let's do that. Sure. Okay, so this is the main Nepenthes web interface page. Right now it's got a bit of data preloaded, just in case scanning locally doesn't go very well. But there are a number of different queues, so things are broken up by basically how much memory they take up, and then how fast they go. So obviously you can have more workers that run with lower memory, whereas the high memory workers usually, virtual machines that you're getting from some provider are constrained more on RAM than they are on CPU usage or bandwidth or anything else. So we broke things up by the amount of memory that they used. So things like taking a screenshot takes a lot of memory. Running Nmap does not take a lot of memory. So kind of have it split up that way. Then we split them up by whether they're fast or slow. So pinging a host takes very little time. So that's something that's fast. Scanning, port scan takes a little bit longer. The idea is that we get faster results back quickly, again, just to get as much data as we can as quickly as we can. It'll still do everything, but it might take a little bit, the slower things will take longer. So most of these are grayed out because there's nothing left to do. You can add some IP addresses. Let's see. I'm on. Okay, we'll go with that. Let's pull. Anybody know what the IP address of their network is? Come on. All right, so we'll just scan our local 24. So you can put in IP addresses. You can put them in as a range if you want. You can put them in as CIDR notation. Generally, we've been able to basically copy and paste any list that we get from a client into this, and it'll work just fine. You can tag things. So I can say, this is the Westin, and this is the lobby. If I wanted to say, like, this is the conference part. You can add different tags. You'll see those when you see results, which has been useful. So we can say, hey, this is in this data center, and so we know it might be these types of applications or whatever. So we can just add those. You can add tags to everything that's on this list. You can also add a region. I'll get to regions in just a second. Actually, probably more than a few minutes. You can see this takes actually a little bit of time to add IP addresses. One of the nice things is that one of my coworkers added is the ability to add IP addresses in the background. So if you're adding just a large chunk of IP addresses, it'll add them in basically blocks of about 100. Again, so you can get things done quickly and move on from there. So we can queue just checking for host names, basically NS lookup. Oops. And you can see that there are jobs working. This should basically drain this queue reasonably quickly. There are still busy workers. That will go down. Also put in pings. Pings can take a little bit longer just because there's a timeout for pings of like 2 seconds or so. We wanted to make sure that we caught everything that was responding, even if it was on a slower connection. But so there are, I guess, quick scans that you can perform from the web interface. The quick scan that we have is just like 10 ports that we decided would be most interesting from a Netpen perspective. So we've got 8443, but we've also got I think MySQL, MS SQL as servers, RDP I want to say as a port, and a number of ports that we thought would be more interesting to start taking a look at, and then we can do full scans as well. If you don't want to use either of those options right now, your best option is to use the Rails console. So I can take the first IP address and queue a scan, and then this again just takes Nmap options. So I can say scan all ports except 0, and it'll queue that, and there'll be one busy worker which is now doing that scan. So all of those sort of work together. I don't know. It works out reasonably well for us if we need anything custom. But again, quick scans are usually sufficient. Quick scans also go reasonably quickly. Right now, there we go. All right. So again, you have 20 workers at a time. You'll usually see them completing in about batches of 20. When we go down to full scans take advantage of all of the information that we have already. So we know, yes, we could ping this host, no, we couldn't. There were ports that we already had open from quick scans. So we'll prioritize hosts that we knew had some ports open to look at those first for full scans. Again, we'll still scan everything, but we're trying to get the most, most likely hosts that have other ports open first. So if it was pingable, it gets added as well into that first chunk, and so on. So let's see. There really aren't many additional open ports here. There's a few. I'll wait for this to train a little bit. There is no automatic refresh right now. I'm just hitting refresh. All right, so we had one open port. That might even be my computer. So you can see down by ports, there's more options. I can try and take screenshots. It'll actually yell at me if I try and take screenshots. When you want to take screenshots, it just points Phantom.js at that port and says, try and load this. If there's anything that came back, take a screenshot and send it back. But that doesn't work very well if you don't know if it's HTTPS or HTTP, because if you try and speak HTTP to a SSL server, it's not going to work too well. So we basically suggest that you do SSL checks first. You can not do that as well if you want, but anyway, then you can take screenshots. It'll just queue these automatically. They'll get taken in the background, and it's actually done now. There are button for Nikto. There are some additional workers that exist that don't have buttons hooked up just yet. I'll talk a little bit more about one of those in a second. But once you're done scanning, again, I had some sample data in here from our training network. You can basically take a look at the list of ports. You'll see, hey, there's, a lot of stuff open on port 80, which is, generally one of the more interesting ones to look at, just because there's a lot of web applications that companies have that are not well secured. Either they shouldn't be exposed, or there's some custom app that they wrote and they didn't realize because it's not their main front end that it's exposed and has some vulnerabilities in it. So when you're looking at a listing for a port, you'll see an IP address. If there's a host name for that IP address, it'll give you that as well. It'll just give you a link to it, so I could open this up and see what this is immediately. Any sort of tags that you had for that host. So we know that this is a public thing, and vuln VoIP or whatever. Any Nmap information on what product was actually listening, you'll get back as well. So, this is Apache. Again, we'll pull in screenshots, pull in any extra data that Nmap wanted to give us. Any of the other workers that we might have had can also stuff information into the extra data there. And then you can also just make a quick note and say, this web server is completely uninteresting. And you can mark it as done and just save that. It'll mark this, keep notes here so you can see what other people thought of it when you were going through, if you're working with a group. And then if you go back to ports, you can also see, how many ports were done versus how many there are total. We might flip that so it's how many aren't done. That's mostly useful in sort of small scale things. If you get to large large networks, this we're not making notes on every port just because it's there's way too many of them. But again, smallish things is actually a reasonably useful feature there. Additionally, so if you go to you can click on an IP address, you'll find another one that's actually interesting. There we go. So you can see open ports on that IP address. Basically the same set of information. If any of them were also web servers, you'll get information on that. It tries to connect to MySQL without any username and password, just in case, because sometimes that actually works. So you can see additional information on that host. Similarly, if we knew that, for example, the client's running a terribly outdated version of Apache that is exploitable, you can say, find me all of the Apache servers, and it will do that. It will say, hey, they showed up on 80 and 443. You can go to 80 and just get, only the Apache servers, and you can do that with, other applications that are identified as well. Okay, so sort of briefly, we had showed some screenshots. There's also a screenshot view, which just gives all of the ports with screenshots. And as you're scrolling through this, you can sort of see some of these are duplicated. And you don't necessarily want to scroll through hundreds of the same front-end server. So there's actually an option to just show only the distinct screenshots, and it'll collapse those down. So this is the same server on HTTP and HTTPS. Some of them you'll get different IP addresses are hosting the same thing, and that's useful to just call out. Hey, I don't really care about the default IIS homepage. Somebody set this up and didn't actually put a website there. Or maybe you do care, but different things that you can look for there. Then we've also got, for completeness, there's a IP addresses tab. When you have relatively few IP addresses, maybe this is useful. The main thing is that you can search for an IP address in here as well. Well, let's not do that. Sure. So you can pull up an IP address if for some reason a client says like, well, why were you hitting this, or what did you find on this host? We found that to obviously be something we need to do from time to time. There's a summary view which some people use, some people don't. You can basically say, give me a table of potentially interesting ports and which hosts had those open. That's partially I'm showing it as hey, it's a feature here, but also this was something that one of our consultants wanted because they felt that it would really benefit their client. Somebody else who had never really written any code for Nepenthes was able to just bang out this report in about 1 to 2 hours, and wrote all of the code for this, made the CSV download, and made everything else. So if you need to add a feature to Nepenthes in basically in the middle of a test, it's really quite easy to just add a feature if you want. Close to the last thing here, I've mentioned regions. Regions are actually something that we had added. Again, my colleague Tomac added support for this as well. Is super useful because sometimes you'll have a client that says, we don't want you to even possibly interfere with our business, so you have to test off hours. So you can only test, from 6 p.m. to 4 a.m. or something like that. Nepenthes will let you set up these options and say, we can only test anything in this region during this time. But sometimes you'll have a client that says, we have offices in Asia, and we have offices in Europe, and we have offices in the US, and we want you to test all of them off hours. So rather than running a bunch of different installations of Nepenthes or running, trying to find the 1 or 2 hours of overlap that you have, you can set up different regions, give different hosts to different regions, and it will only scan things basically during the time it's allowed to scan them. So you can continue scanning all the time, but only the things that you're allowed to do, which has been a reasonably nice feature there. In terms of getting data out of Nepenthes, we've got, we tried to be reasonable about all of the ways that you might want to access data. So you can just, get a CSV file that contains all of the open ports on which hosts. So if you, need to process this somewhere else, you can do that. And that, again, just gives you a list of everything that was open. If for some reason you want to say, like, give me all of the web servers, again, you can go to, just get a text listing of all of the IP addresses that had web servers open, or at least had port 80 open. Again, you can do that with a product. You can do that with pretty much anything that comes up here. And then as one of the other integration features that we had that was useful, because we're doing Nmap scans, we're doing them with XML just to be able to parse them. A number of other tools will take out Nmap XML. So we have a feature that will just sort of shove together all of the Nmap XML data that we got out into one large file, so you can import this into something else that takes Nmap XML, and it will read it as if it was one large scan. There are a few reasons for that. Our main reason for doing that was to integrate with Nessus, where in Nessus 5 you could actually take a list of IP addresses and give it Nmap XML, so it would not do its own port scans. It would just assume it knew which ports were open, which really sped up Nessus for us as well. In Nessus 6, that option appears to have been removed. They claim it's no longer supported. I'm not entirely sure why. But then, in keeping with it's relatively easy to add a worker to Nepenthes, I started a few weeks ago adding a worker that uses the Nessus 6 API to basically just clone an existing policy that you have in Nessus. set up the specific ports that it knows are open for a given host, start a scan on that host, wait for that scan, pull the scan results back into Nepenthes so that you can view them and browse them there, and then deletes the new custom scan-in policy just to leave things back where it left it, or where it found it. So that's a feature that exists in the Nepenthes code, but just because the Nessus 6 API is actually really flaky, we haven't pushed that into the user interface yet until I get a little bit more comfortable that it will not just completely trash the list of available policies and scans. So anyway, a bunch of different options there. Let's see. Undo this. Okay. All right. So to use Nepenthes, it's public on GitHub. It's free, open source. Take a look at the README, please. It sort of walks you through installing it. Installing it is actually reasonably easy. It sort of expects that you have a somewhat recent Ubuntu server VM. There's a script that will just download and install all of its dependencies, set them up, and basically spit out a username and password to access the web interface. Again, the idea is that the Sprout has more sensitive information. You probably want to host that locally, and then tendrils can just be hosted on some cloud provider if you want. You can also host those locally. It doesn't really matter. But usually, cloud providers have either better network access than you have, or we've run into issues where our ISP doesn't work very well if you're trying to open hundreds of thousands of connections in a fairly short period of time. So again, those are useful. You can install it locally, just like obviously I have it running on my laptop. Don't use the scripts for that because it might clubber things that you're trying to do. Anyway, try to avoid exposing the Sprout to the internet. We're a security company. We tried to write it to be reasonably secure, but we haven't actually looked at it too carefully with an eye for securing the actual interface. So if you do expose it to the internet, you might want to take a little bit more close look at that. We keep it internal anyway. It's got password on it, so that's reasonably limited there. So if you want to actually add things to Nepenthes, again, it has basically the core concept of workers that do things. There's a worker that works on the tendril. There's a worker that works on the Sprout. So you can write a worker to grab a host name. You can write a worker to run Nessus. You can write a worker to ping things, whatever. Do something with a worker. Take that data, process it, and then basically send it back to another worker that works on the Sprout to store it into the database, do any sort of additional processing that needs the database. And then get back to the UI. You can display things pretty much however you want. There's a bunch of options there. But for an example here, this is what the hostname worker looked like until very recently. There's basically like 6 lines in here that aren't boilerplate for every worker. So if you want to write a new worker, super easy to add. And you can basically just copy one of the ones that exists there. There are ones that shell out to other tools. There are ones that just run code in Ruby. Then the other side of this, getting back, storing things in the database, again, super easy. Look up an IP address, save the host name on it, save the IP address, and that's it. It's just largely boilerplate. It's designed to be pretty easy to write. When you get to the user interface, the idea, of course, is that it's easy to add things, easy to modify any parts that you want. Being able to use all of the data that's available there. Again, if you have used Rails, it's all more or less as you'd expect it. If you haven't used Rails, things are related, so you can go from an IP address to its ports, and from a port to any screenshots you might have. Any sort of relationships like that are easily exposed. And the idea is, we can do things like find duplicate screenshots and just sort of mute those where necessary, or you can say, hey, pop up a warning that says you don't actually want to test this host right now because it's out of your testing window, or whatever. All kinds of options there. Got a little bit of extra time here. So things that we might want to add in the future, don't have these yet, but these would fit in pretty well and would be actually kind of easy to do with workers. or adding things to the user interface, just having some GUI for custom Nmap options. A lot of people don't know all of the options that Nmap provides, and the man page is good but not great about explaining them. So just being able to check a checkbox for like don't ping this or whatever could be useful there. Taking VNC screenshots, RDP screenshots is something that has been popular somewhat recently. We haven't actually found it to be all that useful. It's something that Nessus will do, but again, it's not something that we've actually seen be too common, so we haven't actually gotten around to writing a worker for it. Being able to just pull the HTML that we saw when we took a screenshot is actually something that I really wanted to be able to do, because we can identify, like, this is a Dell DRAC, and we want to try, default credentials on it, or whatever. And being able to identify more of those applications than Nmap will do, or Nessus will do, is something that would be kind of useful. Similarly, just being able to handle domains. A lot of things are virtual hosted now, so, you're just going directly to an IP address. You may not actually see what's there, but we might have a list of domain names from a client, or we might be able to make one. And then being able to brute force subdomains, so maybe there's webmail somewhere that we didn't know about, or those sorts of things would be useful. Haven't gotten there yet. We're actually kind of getting to the point where that's kind of the next feature that we want to add. Adding workers, doing any sort of processing. Right now, the defaults for the scripts that will install it and run kind of assume you have 1 GB of RAM, because that tends to be really cheap to get on cloud providers, but it doesn't scale automatically when you get more RAM. And then I guess just the last thing there is UDP scans is not something that are actually supported in Nepenthes. It just sort of assumes everything is a TCP port. UDP scans themselves are kind of tricky, just because there's no guarantee that you'll get a reply even if something's listening. So, being able to add some of that would be useful, but is not something that we've done just yet. If you are using Nepenthes, some rough guidelines. Usually, clients will want your IP addresses that you'll be scanning from in advance. So make extra tendrils, make extra VMs, and give them those IP addresses just in case. We've found kind of the trade-off between CPU usage and RAM seems to be about 4 GB of RAM is good. You can scale to a reasonable number of workers there, and still not outstrip your CPU availability. There are low memory workers. We can do about 40 of those per gigabyte of RAM. High memory is about 4 per gigabyte of RAM. If you get into some really advanced configuration, you might separate those so that you're not trying to oversubscribe your RAM between low and high memory workers. That's kind of out of scope for most of it, and generally hasn't been an issue for us. But in a few cases, that's been useful. So consider it if you're working on that. But I believe that's about it. A little bit early here. Any questions about anything? None at all. Sure. So yes, both. So for example, if you tell it to ping like an entire /8, it will use that information for the next scans. So it'll start by only looking at hosts that were pingable, but we know that not everything responds to ping, so it will continue to do everything else, but it will start with the ones that it knew were live. So it tries to be smart about that sort of thing. Other questions? Oh, okay. If you have anything else, feel free to find me afterwards. So, thanks.